I'm going to continue to add to what Piers had talked about, but I'm going to take it in a slightly different direction with the agri-politics, because these changes that we're seeing on our planet right here, it's all about the food. Because whether it's Extinction Rebellion saying that in 12 years there won't be enough food to feed the planet, or it's the jet streams bending because of solar activity, at the end result of that is there's not enough food to feed the planet. So instead of arguing and bickering about who's right, who's wrong, we should be thinking about solutions, because at the end of the road, we all agree on something, warming, cooling, whatever. There's not going to be enough food. Our crops are being affected. It's not going to be, they're being affected now. And I'm going to take a look at what's happening in some of the areas of the planet where the crop losses are the heaviest this year, and it's anticipated to continue to amplify through the next few years or decade plus. So it's not going to be a small event. So whatever the end of the road is, we all agree the food supply on our planet is in jeopardy if we do not think of solutions moving forward. So this is more of a solution session, as well as defining the problem, so we can come out and work together and talk together instead of pointing fingers at each other. Think about solutions together, because this is the way we as a species are going to have to get through this. It's not about me sitting in a basement for 30 years eating canned beans. That's not going to work. We're going to have to adapt our agriculture based on these changes that are occurring in our climate. And I hope to present my side of the story, because in the mainstream media, you're already seeing the almost 95% of it or so is CO2 based explanations for why the climate's changing. Fine. I want to present my side of it so I can add a little bit more in where maybe some pieces are not put or filled in because of the corporate media, the way they try to roll out the narratives that they're getting paid to do so. What about this other set of information out here that Piers talks about, John Casey, Dr. Abuzamatov, myself, and quite a few others that say we have a huge problem with what's going to happen with our agriculture, and is right now. So I'm going to start to talk about food here, because the food is going to be the most important thing. Now, as we move through, please remember that even if we get devastating losses, as they saw, this is from 1755 all the way to 1800, and the dotted line is the wheat price and the solid line is the rye price. Now notice the profile here. Even though they had humongous losses, gargantuan losses, and the food prices went up 4x, they did come down though when they had some more stable growing seasons, and then it seemed they went through a pattern type of loss and gains in their agriculture at the time. And whenever there's losses, it was up 4x again, but then it dropped again. So it's not going to be incredibly rising food prices into infinity where we're going to go down lower, lower, lower to zero. That's not going to happen. But we are going to get a profile, something like this, as the jet streams undulate through the magnetic fields on the sun when they're canceling, and we're going to go through 2 waves of this. So I'm going to show you a couple more things. And again, we see the same profile here. This is from 1655 all the way to 1702, and this takes into account places like Paris and Amsterdam and Brussels at those far times back during the Maunder minimum. But you can see again the food prices that had spiked up, depending on the crop, anywhere from 2 to 7 times on this, and then back down again when they had more stable seasons. But then the losses again came in with unstable growing seasons. This is what the shifting jet streams and the undulating polar vortex or the equatorial vortex is going to lead to. Shrunken growing seasons, out of season rains, and what we're seeing, droughts in some areas. All a result of the jet stream. Now again, Maunder minimum, you should be most familiar with it as here in the UK is the most studied area on the planet, hands down, what happened during this time. They went by county to show the crop losses across all of the UK at that time, England basically. But the Maunder minimum profile like this, solar activity is going to drop back down, and then you saw that it came back out, and then solar activity increased, so did the crop production. And you'll see that we rise and we fall, our civilizations, as we move. But do we have more modern example of what will happen if crop prices spike? Of course we do. Now here's the thing, there's two things intertwined here. Credit, the just-in-time delivery system, and financial crises or economics. Now the three things that always happen during a grand solar minimum are the food price rises, and then the economy contracts because people spend more on food. Secondly, people migrate, they have to. And then thirdly, the loss of the crops should be experienced. So you're going to see these three things for sure. Now what's going to happen if the commodities prices spike? Well, we already know what happened in 2008 and 9. Credit locked up. But in today's global delivery systems, you need credit to make food move. Because nobody's paying cash for a 40-foot container of beans and then paying cash to a freight forwarder and then paying cash when it lands in your country and then paying cash at delivery when it hits the store. Nobody does that. It's all letters of credit from 30, 60, 90 out, and if that locks up, so does your food supply. So thinking about local production and your local area, and those of you who have the skill to grow food should be sharing the knowledge with others, starting community gardens. Is there empty space where you can work together? But food is going to be essential, and the closer it is to you, the better, because we already see what happened. You remember those price spikes back then? Oh, petrol went up, everything went up, food, metals, and then we locked up the credit system. And it's taken how long to get back to some normalcy? Well, what if it happens 2.0? There'll be no more bailout because it didn't work the first time. So the 50 trillion they put in to stabilize markets and reinflate the global economy, it won't work. We're done at this point. So when it goes the second time, because of spiking food prices, there's going to be no more bailouts. We're on our own. Now again, it's about the sunspots that lead into the solar cycles, that lead into the civilization cycle. Because we find these massive empires that have risen and fallen, why did they collapse? They were the biggest of their times, the biggest of their eras. Things you might have heard of: Babylonia, the Babylonians, the Akkadians, the Hittites. When we come back through and we take a look at the Fertile Crescent and we go over to India, into Harappa, why did these giant civilizations collapse? The Maya, everywhere you look, Chinese dynasties. They're rising and they're falling for some reason, and it's because of solar activity and the amount of food available to an empire or king or fiefdom or whatever it wants to be. Myanmar. The reason I put this up, this is what got me into this entire area of study. Now, also what I wanted to show you here is in the center of this image here, this is the fertile growing belt of Myanmar that is only 50% used. So as we look tonight at countries that are going offline or could produce more food, this is one of the countries that could increase its production by at least 50% more. And they used to be the grain basket of Asia. Back in the 1960s, they produced more rice than China did. So when you think about areas that governments are going to fight for in the future to get access to food, to keep their societies functioning, you're going to look for hot spots in the news, areas on the planet that are starting to come online and get greener. I used to buy coffee out of Myanmar. The gold right here, Mystic, Myanmar, Burma, used to rule that place for quite a few years there. So it was about buying coffee. Now when I was there, the farmers were telling us when they would plant these smaller plants, these are the 1-year-old plants, and if you want to get coffee, you have to pre-buy it. So they have to plant the fields for you, and then you get extra production as it comes online. Now the farmers at the time told us they were overplanting by 12 to 14% because of cold weather crop losses. Now for me, I used to believe in global warming 1,000%. And when I heard this, it made no sense. And I said, are you sure? You're losing, it's supposed to get hotter. We're in Burma or Myanmar. How are you losing your crops and the seedlings 14 to 12% per year that you have to overplant in the fields? Also, these plants that you're looking at here, the coffee trees, these are between 3 and 5 years old, and you have a silver oak canopy here. But the top leaves were getting burnt from cold damage as well. And the beans, they were getting these microspherical pockets of water in there that would freeze solid in the winter, and when it thawed out, it left these little pockets in the beans, so the density was less. And I'm thinking to myself, whoa, your beans are freezing solid up here, and we're in Myanmar, and those are turning solid ice in the winter a couple of times per year. And you're burning the top of the plants, and they go through and trim out all the dead after the spring comes, and then they wait for the flowering process again. And they just count the losses again and again. So I just wanted to introduce myself really quick. Some of you do know that I run a YouTube channel, Adapt 2030, and the podcast Mini Ice Age Conversations. Others of you might be the first time you've seen me or heard my voice. But thanks for coming tonight. I appreciate us trying to get some ideas together to work together here. Now, the Maunder minimum has been reconstructed really well. This is the best minimum that's been constructed, temperature-wise reconstructed, above the Dalton minimum in the 1800s. So notice a couple things here. Alaska, we keep hearing Alaska's getting warming, Alaska's melting. Well, look at that. It got warmer during the Maunder minimum. And then we take a look at Greenland. You're hearing about southern Greenland. It's melting, it's melting. Well, it got warmer during the Maunder minimum also. And then the devastating crop losses across Canada and the United States are, 100% match in this blue belt right now this year. And we come over here and we look at places like North Africa and Morocco with record snows, record rains. And then we get the cold that's already killing off part of the Russia's production up here in this area. And you start to see the matches again as we move over. Now these are some interesting spots here in China, in Xinjiang. They're becoming much wetter up here, so China's moving the chess pieces around the board. Now here's our sun. Now to put this into consideration, where is our Earth compared to the sun? Basics, yeah, the smallest one, but which one's smallest one? That one? Which one was it? Nah. Yeah, there you go. It's the one with the moon. Now take into consideration, this thing is over 1 million times larger than our Earth, and it's just right there. You get a sunburn on the planet's surface. So take a look at that and understand that this solar cycle here is just a single one. And then you can couple them together into longer periods of time. And this would be about a century here, but then we take a look at, 12,000 years of cycle time. Because the media and the corporate media and the IPCC try to squeeze all of our climate into the last 150 years. And they base all their projections and movements and forecasts, and it's warmed here, on 150 years of data. Why don't we look back at the last 12,000 years and see these cycles repeating, heavier cycles on top of cycles. And that's what I believe we're into now. A far more powerful, heavier cycle overriding the 400-year periodicity this time. So you can see how it stacks up. So the black box here is all of this time here compressed as just this little amount of black box that the entire climate debate of all the charts only encompasses this much of our entire temperature record. And that's a travesty, truly it is. We should be like Piers talked about, spikes, the Minoan warming period, and the Phoenicians, and everywhere else we go back in time. Now, where would these crop losses be occurring first? Well, we just need to look back in history, and these were the witch trials from 1550 to 1700 in Europe. Now again, it was about blaming somebody for the changes. Had to be blamed somewhere, didn't it? Who are they blaming this time? Us again. Why is it a group of people being blamed yet again? It's just 2.0. Is it not? They're blaming us again. Before there was a culpability, it was witches. No, it wasn't. It was not in any way, shape, or form. It was a natural cycle. But one thing that this does give as an indication is where the heaviest amount of weather changes is where the people were most spooked, scared, afraid, and unprepared for the changes. So they had to blame somebody. So when we see these clusters of dots, look where you are right here. You know, I was down in Totnes the other day, but that's, you know, look at that cluster right there, and also up in the north. And then, you know, you see parts of right there at the border of France, and we got, you know, central Spain down here, Italy, Slovenia, come all the way over and you get into Bulgaria. Massive crop losses this year, the corn crop. So the magnetic fields that we look at, they look so pretty with the NASA renditions, but in actuality, they're not. The magnetic fields of the sun look something like this. They're strewn about, they're coming out, there's magnetic fields, these things are flipping every 11 years coming back, and there's, you know, quadrupoles on there and it's moving through. So when you connect these in space, it really looks like this, more or less. The magnetic fields from the Earth coming up, connecting, intertwining with the magnetic fields of the sun. So when the sun steps down in charge, what do you think is going to happen with our Earth? We're directly coupled to it. So what effect is our Earth going to have after the sun steps down in its charge? And again, I need you to visualize where we sit in the cosmos here. Because if you come out off the photosphere and you get to the corona here, Earth is just so close in the Goldilocks zone. I mean, we're almost getting burned from the sun. You step out, you freeze to death over in Mars. You come in, you boil over in Venus. We're in the Goldilocks zone here. Now this is called 1 astronomical unit, like 1 AU from the sun. So how far we are from the sun is 1 unit. Now the magnetic field of the sun stretches 100 AU past where we are. So we're literally in the top 1%. Literally, we are the 1%ers. We're in 1% within the top, we're 99% closer to all the other changes magnetically on the sun than any other place in the entire planet. As far out as this thing goes at 100 AU out. So the effects from our sun is going to affect us drastically, nearly instantly, and it's going to be noticeable, let's say. So I'll bring you back here to the sun again. Take a look. That's 1.2 million times larger than us, with a field of magnetic intensity intertwining with our own Earth that goes 100 times further out than what you see. You know, you're looking at 20 AU out at the furthest planet. So since we're here in England, I thought I would like to drop this chart here. And you can see low solar activity boxed up in the low solar cycles. And you come down here, and what do we see? Well, we see drops in temperature. And all you do is you just follow the box down, dropped in temperature. So here we are. What do you think is going to happen here? We're following the same profile. Higher solar activity, dropping in on low solar activity for a couple of cycles. High solar activity, followed by low solar activity for a couple cycles. We are expected to drop down to here. What do you think is going to happen with the temperatures on our planet? About the food. This bright thing up here shows us and gives us the amount of food that we can get. And again, if we don't have enough food, we get scenes like this, but you can't control everybody. There's not enough military. Hence 5G, in my personal opinion, using weaponized frequencies to control crowds that are going to be fighting for food, looking for food, and fighting the police for food. You won't have enough military to shoot everybody with machine guns. And morally, I don't think most soldiers would fire on their own citizens, hungry people. But a wave, you sit back behind the desk and you go, oh, we're going to grid down this part of the city. Oh, we can control everybody and make them vomit and bring them to their knees with a certain frequency. How convenient would that be if we can roll it out across continents that might get angry? We're already seeing empty shelves across America. I mean, I've done several videos on like places like Walmart with their own vertical farms and integration, packing, shipping that are running out of food. Makes no sense unless there's another huge buyer somewhere. And who would that be? A person, an entity that could buy enough to empty shelves across a country. It can only be the government buying that much canned food. That's it. So we start to see that if they warn us and tell us truly what's going on, we're going to interfere with their supply chain and preparations. And when I say they, I'm talking about governments, continuity of governments. If 8 billion people wanted to buy canned beans, there would not be enough ever, and it would lock up the supply chain. But if they don't tell us and let us wander into the wall at 100 miles an hour with no airbag, they can continue to prepare behind the scenes, buy whatever they want because we are unalert, and this is the reason I try to bring this information to you. Now I made this map just recently. There's 4 tiers on the map. Red are the countries that are losing massively crop production this year. Slightly last year. This year is at the all-time record of crop losses across where you're seeing red. Australia is now a net wheat importer. They can no longer grow enough to export wheat any longer. And we saw what happened with China. They had the army worm, and they also lost 35% of their crops due to the army worm, and then they had the swine flu with the pigs. America lost 40% of all of its crops this year, and Canada around 30%. South Africa, it's almost offline. Now the blue are the countries that are going to be going offline second or reduce production further down the line. Not right now, maybe like 5 years, 6 years, 8 years. But Brazil, China's heavy in Brazil, Argentina, India, and Kazakhstan. So these are some of the other countries, Indonesia. Oh, and anything that's in yellow is a place on the planet that could increase production. So then you start to look around and go, gee, I have never seen any of these names in the media before. You can increase food production in these countries. So let me do the check the box. Ukraine, heard about it in the news. Venezuela, heard about it in the news. Myanmar, Burma, heard about it in the news. What about Indonesia lately? So that can't be a coincidence that 4 out of 4 are now tumultuous at best. And other people want to get in there, change the government, change everything about it, the way the structure is, and then change the banking and then build new ports. And it's just a coincidence? I don't think so. The gray was what I didn't have enough information to fill in yet. Oh, can you go back to that one? And the green is the new grow zones that are coming on. So North Africa is getting much wetter. They're going to start irrigating crops up here and bringing on new production globally. Now, if they bring on the green area here, that will equal all of North America, all of it. It'll actually exceed North America because they'll get longer grow seasons with the more intense sunlight. So what's happening in Africa explains some of the immigration, some of the infighting, and a lot of strangeness that we've seen. Yemen, heard about Yemen in the news? Yeah, deep water port, new grow zone. Oman, really wet. How about Iran? Massive floods. Wait, a new grow zone's emerging in Iran as well. It's not coincidence that there's like agri-politics at work here. Now the grand solar minimum, one of my friends said, hey, my child, I want to explain it to my child, but they might understand this graphic better. So I said, all right, cool, put it together. So the grand solar minimum, what you could expect. Again, our sun's going to start to go to sleep, so we're going to get more cosmic rays. More cosmic rays are going to cause more volcanic eruptions and more floods. We're also going to see wavy jet streams, just like Piers talked about. We're going to get atmospheric compression events, like rivers from the sky. And then we're going to have trouble growing our crops. And this is what it's about. Food, 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 and food again. Chill of the solar minimum, the thermosphere is decreasing in temperature. So as we take a look here, it's at the all-time low, well, as far back as they have records for. It's the lowest. That actually broke through and is down at the 0 level now this year at the bottom of solar cycle 24, and it sure hasn't gone anywhere but down from there. So if you're talking about upper atmospheric temperature levels, this has decreased already, and coming from the top down to our Earth's surface, this should cool first and then down here second. So if this is cooling, well, we should expect some cooling on Earth as well. Now it's all about the electricity, electromagnetism. Again, the sun is charged differently from our Earth, now, but it's going to step down in its electrical output and luminosity. Watts per meter squared striking the surface of the planet is going to decrease slightly. But electrically, it's going to step down too. So that means our Earth has to step down its charge and match. So the bottom is a rendition of maybe what the sun will do electrically. It's going to step down. But if we're overcharged, it has to equalize or release somehow. Maybe that's why we're seeing more intense electrical storms. Sprites, these sprites that are at the top of thunderstorms. Blue jets, all these types of electrically amplified atmosphere. And they call this a global electric circuit. And what we're really starting to see now is an enormous amount of ground-to-sky lightning. And that's an upward discharge. And then the sprites are here, and then we have the blue jets, which are over every single typhoon or circular storm. Could be a hurricane or whatever you like to call it, cyclone. But they're on almost every storm now, which is unheard of. And almost every electrical storm or thunderstorm is now showing sprites. They were once a thing of legend. That's how infrequently they were sighted. But now it's almost every single storm, and they're staying up there for like a second now, where you get incredible luminosity out of them. Now, this is a plasma filament here, and it's called Steve. Now, it was only sighted in 2017, so the person who saw it first named it Steve. Now, it's been seen more than a dozen times, but I just don't have all the photos, but this was the slide just from last year. Now, it moved from this semi-luminous over to here where you can see the intertwining current lines on this thing coming down. Now, do you think which one's stronger, this one or this one? This is where we've gone to at the beginning of 2019. It's definitely stepped up since that point. So we're seeing changes everywhere. Now, if you're talking about petroglyphs and things that the ancients saw in the sky, they witnessed, they chiseled it in rock as a warning to us. When you see this up there, massive changes are afoot. Now, if we're seeing this first plasma rope, we have at least the center of the squatter man. Now, it has to be more highly charged before we're going to get the arms or we're going to get the apron coming off of this. But so far in the skies, we're already seeing at least the center column there of the squatter man forming in front of you. So we're literally seeing something that was carved in Chaco Canyon in front of us evolving. Now, how much longer will it be before the difference in the charge and the equilibrium there is going to amplify this? It's going to go into glow mode and we'll all see it. And then how would you describe it? I would be joyous but petrified at the same time, and I would sure chisel it on the side of this building like we just saw this thing in the sky. Now, solar wind, it should be another indicator. If the sun's starting to go to sleep and there's lower solar activity, we should see some effects with the solar wind as well, and Piers alluded to this. So the top here, we have the nice tight solar wind buffeting against our magnetosphere, and then down here, no solar wind. That's this year in January. And again, it happened a second time where it was, you can see the solar wind compression on the frontal boundary here, but then also whoosh, no solar wind. Look at that. The compression let off. What do you think is happening to our magnetosphere, and how do you think our jet streams are going to move when that happens? There's going to be no pressure. So when the pressure comes off, they can just kind of undulate wherever they want. Next. And again, just a different example. This is a different view, or taking a look at the density of the plasma per square gram on there, or per square centimeter on this by the gram. So you take a look here, compression, solar wind, whoosh, let off. So you can really see how it puffs out and it lets off when there's no solar wind. Now, this has happened twice in the beginning of this year. It's beginning, and these signs are all around us. And when we come to low solar activity, the cosmic rays spike, but there's about a 9-month lag period between the end of the cycle, and you can see where the spikes on the cosmic rays are just slightly after the end of the solar cycle there. But what does that mean for you and I? Well, the cosmic rays are about here at the moment, and during the Maunder minimum they rose up to here. The changes we're seeing with the rainfall patterns, the volcanic eruptions, this is all based on cosmic ray bombardment. But this is like an energetic particle that contains knowledge and light. So if you want to think about us increasing bombardment with knowledge and light as a particle, again, are they using 5G to try to use some frequency to nullify that, so that knowledge wave is not allowed to come through our physical space? Because some of these things I've been talking to 5G experts about, and are we able to offset, and not me, but them, the people that are trying to install 5G? Because the cosmic rays are going to increase another 25% or so as we go through this cycle, and those are responsible for cloud nucleation and how clouds form. Now there is some dispute on this, so it's not 100% agreed on across all the sciences. It's still being worked on as a model, shall we say, on really how much input of cosmic rays is it comparatively to how much cloud it forms in the atmosphere. But for sure there's a causation of silica-rich magma chambers to eruptions in volcanoes. Because again, silica, think about crystals. You can encode knowledge in crystals. And we're being bombarded by energetic particles of light and knowledge onto the thing that could actually store it, the silica, and these are the volcanoes that erupt. So you can twist it into a bunch of different areas of science as we look through it. Now what they're finding though is the cosmic rays are up to 7 times more impact for cloud creation than they originally thought. But as we take a look at the cosmic rays, it's just up and up. Wherever you go on the planet, it's the same signature, up and up and up. And the latest one I could find was January 2019. I couldn't find anything more recent. Now the magnetic pole is also in its wandering phase here. So how much of it is magnetic pole movement versus CO2? Because if this thing moves 2 degrees, or 120 miles, 2 degrees latitude, or 120 miles, what about 5 degrees latitude, 300 miles? This thing is moving at 120 miles per year now. So as the magnetic poles are moving around, perhaps that's part of this shift as well. So now we have all these other parts with magnetic fields from the sun interacting with us, on our magnetic field of our Earth is moving around, cosmic ray bombardments in there. We got all the pollution that we put into our atmosphere and into our waters. And how much of it really is CO2 that involves warming? For me, there's a lot of heavier, dense cycles and particles and other things evolving on our planet that could explain a lot of these changes. Now, CO2, is it in there? Yes. How much of a causation is it? Not sure. Nobody knows. But I would really think the magnetic coupling of our sun would have a greater impact in cosmic rays, and magnetic field movements would, than CO2. But I challenge you to do the research. Don't listen to me. You do your own research on that and really come up with your own conclusion. Like here's an interesting one. European Space Agency used to show where the magnetic fields were moving, but they moved too fast, so they stopped publishing the data. 120 miles a year is a scary thing, because in 3 years that's almost 400 miles difference, where if I take you 400 miles south from where we are here, what's the climate going to be like? Let's move 400 miles south of here. How would that be different? Yeah, quite a bit, eh? And then there's a considerable connection between how much cloud cover there is and how many galactic cosmic rays are coming in. So long story short, more cosmic rays, more clouds. So this would also have maybe something to do with cooling temperatures, because more cloud cover reflects more sunlight. And Svensmark's really the one you want to look at. So I'm going to drop you a little breadcrumb here. Heinrich Svensmark. Now again, you know, what CERN did with their research and what Svensmark's talking about, you know, there's still more conjecture and more study needs to be done about the true effects of this, but there seems to be enough of a correlation to put some peer-reviewed research out there and get it passed through the process. Now you can look at this movie, The Cloud Mystery, here, and it'll give, it's like the perfect, it'll be well explained better than I can do it. But again, these are the jet streams and the cloud cells on our planet. These things are moving around because of electromagnetic effects from the sun. CO2 cannot go that high in the atmosphere and have an effect on the jet stream this far up and then bend these cloud cells and cause different circulation patterns. It's 4/100ths of 1% of the atmosphere. Not even 1%, 4/100ths of 1%. And then nobody talks about the intertropical convergence zone moving on its 400-year cycle either. I mean, look at this. We got the actual area where the cloud cells are moving off the equator moves this much during grand solar minimums naturally. But nobody wants to talk about that. It's too inconvenient, because how do you explain the shift in that? It's a natural cycle. And then here's the result is our jet streams. These are vertical jet streams now. This is earlier this year. Actually, when I was speaking up in London last time, this was the actual forecast for the UK here. And look at these jet streams, how they're undulated. They're vertical. That shouldn't be like that. It should be more, well, it shouldn't even be like this. That's too much dipping. But we can see the jet streams are, well, I wouldn't say broken, but they're in the wrong places in the wrong seasons, causing unseasonal air. So look at this, equatorial vortex bringing extreme heat up into the northern areas, where we get extreme cold plunging down to Florida and Cuba, and places super far south. Now, for those of you who are into astrology and astronomy both, top 79 AD. Now, you'll notice that we have this configuration where it makes a square in here with the Earth in the center, and then we come down to 2024, and we have the same configuration with the planets with the Earth in the center. I use mapping software where you can see, you can rotate the planets around and go back or forward in time to see planetary geometry. It's 1 degree difference between 79 AD and what we're expecting. And it's interesting. It's October of 79 AD and October of 2024. This is a 2,000-year cycle here, planetary-wise. So you have to ask yourself, do you believe in the planets and the astrology, astronomy? Can planets affect us? Can planets affect our being, our consciousness? Because you see a lot of protests going on the planet right now, everywhere. So it seems this wave of consciousness sweeping through whatever, there's a lot of changes going on, physically, metaphysically, as well as earth changes. And then I like to do this one because I have to get a little bit closer to read it. Why is Singapore heating up twice as fast as the rest of the world? And then it says the mountains are warming twice as fast as the rest of the world. Britain is warming more than the average. China is warming faster than the global average. Europe has been warming faster than the global average. Spain is warming faster than the rest of the northern hemisphere. Global warming is happening twice as fast in Alaska. Australia heating up faster than the rest of the world. Sweden is rising more than twice as fast as the global average. Adirondacks, that's an American mountain chain, is warming faster than the global average. Canada is warming at twice the global rate. Russia's warming faster than the rest of the world. And global warming is impacting Switzerland twice as fast as the rest of the world. Oh, and Finland is warming twice as fast as anywhere.
The world is warming twice as fast.
That's right. That's exactly what it is. You hit it on the head. The whole world's warming twice as fast as itself everywhere else because it's warming twice as fast, basically. And this is what they're feeding us every day. Now, how can these headlines be so similar yet everywhere? That's impossible for that to be true. Keep it going. And another one I like to see here, all right, now this is the El Nino in late 1998 into 1999, and it was the warmest ocean sea surface temperatures we've had to date. Now the new excuse that there's all these record rains and all these record snow, now this is the pivotal point. The explanation for record snows right now is heating oceans, correct or incorrect? Next slide. If it was correct, then we should have seen record snows in 1998 because this is only 1/10 of a degree warmer on this spike here in 2016-17. Now, if they're telling you the cause of record snowfall is warming oceans, then why do we not get the same outcome from this and this? They're both identical, but we didn't. I was told snow would be a thing of the past. My children will never know what snow was, is what I was told. And that's what they told us right here. All the warming and heating oceans, you never know what snow is. Snow's the thing of the past. Sell your ski resorts. And now they're telling, oh, well, because of heating oceans, it's record snow, it's your fault. Pay a global tax, we can stop the heating oceans. Now the thing is, when these intertropical convergence zones shift, we already know where the rain patterns are going to shift to. They've already done the reconstructions. There's thousands of these reports out there. Go to a PDF search engine and start looking. Thousands and thousands and thousands of locations have been mapped of what happens in these last 1,500 years of time focused mainly on the Maunder minimum and the Sporer minimum on where the moisture shifted. They already know it's going to get wetter. They already know where it's going to dry out. So look at this in here. Parts of Australia are becoming what? Wetter and cooler, and they already know up here what's going to happen. So you're looking at how much rainfall on this chart here, and you go, whoa, it looks like much more rainfall here, but look how it moved north, and you get the west part of Australia get wetter, the central, and then look at that. What's happening in today's weather? Pretty much match. So you already know where it's going to move and shift to. And here we are, record rainfalls in Australia. Gee, really? I just pointed out to you, they already knew where the rainfall was going to shift, central and west. So here we are. Look at that, record rainfall, 2016, 17, 18, 19. This is the Australian outback in full bloom now. We could grow crops there now too. This is the shift that's happening. Now also when you want it, this is very specific for specific time dates. As we move through the Ming Dynasty, we start to see where there's dry pockets in northern China. They couldn't feed the people, so the Ming Dynasty collapsed around that time. So as we start to look through, we see where the drought areas are going to unfold based on past cycles. So now all we need to do is match the time and the place, and we can get a good indication, is it going to get warmer, or is it going to get hotter, or drier, or wetter, or cooler? And if I'm going to grow food, I'm going to take over that country if it's going to get wetter and warmer, or wetter and I can grow food. My troops are not going to fight if they don't have food, and if they don't have food to give their families, they're not going to fight. And this is what they learned from the Roman period. If you can't feed your troops and their families, they go home. So getting food is going to be the utmost number one important thing for an army that's going to keep moving forward and grab more resources. The food supply is the number one thing they're looking for right now. Oil and energy, that's old news. Food is what they need, or their civilization disappears. And that's us, wherever you live regionally, continentally. You know, more snowfall, of course. Sierra Nevada mountains. We were told snow would be, in California, the experts told us, well, it's going into a 100-year mega drought. There's going to be no more snow, no more rainfall. Sell the ski resorts. Don't ever sell your skis. You're never going to ski again. And then 2 years later, record, and it's like the second year in a row it's been record snowpack. Experts missed it 2 years later, so how much of experts are they? Now there's so much water coming in here on these things called arc storms that they need to classify a new category of arc storm, that's a 5+, because they know the rain push is going to be heavier and heavier on these new arc storms with the new jet streams forming. So they're already making a new category so you won't get spooked. Oh, we already have 5+. We know it's 5+. This is an interesting one here. This is the bloom dates here. Green is early and purple is late. So look in the United States here. It's really interesting. This particular part, you have some of the earliest blooming ever right next to some of the latest blooming ever. And then we get up here where we lost the potato crop and the corn seed crop this year. And we have all this in the United States. We never planted on time either. And look at the desert Southwest in the United States. 4 times the normal amount of rain for the second year in a row. This is the desert Arizona, New Mexico, Anasazi Indians. They all left because they dried out. Now the rain's coming back because this North American monsoon is shifting to push, that arc storms you saw the water coming over the Sierra Nevada or the California mountains here. It was coming like east to west and it couldn't get over the mountain range. But now the North American monsoon is shifting, so the water comes up or the moisture comes up from Baja Peninsula straight into the desert now. Greening as well. Now American floods, we lost an enormous amount of crops this year, the most ever. Lowest yields ever in America. This is a normal flood stage in the spring when it floods every spring. This is this spring. Incredible amounts of floods. I mean, this is in flood stage, like major flood stage is this one. And this is what occurred this year, like biblical flood stage. And this is a result of it. So this bottom picture is pretty much a single image to sum up American agriculture this year. We got busted bins. We lost an enormous amount out of the silos that got run over. Major flood stage through Nebraska, normal year, and then you get this massive thing happening here. Roads are washed away. I mean, they're never going to refurbish these fields. It could take years to get this fixed again. So what we couldn't plant, well, we're not going to plant again next year. Atacama Desert, driest place in the world. Wait, second super bloom in a year, record rains in the Atacama Desert. 2 years in a row. Let's see if we can make it a third year. Where's this little nugget taking place here? Look at the massive floods. Afghanistan. Now, if you can think, that's Afghanistan. These rivers are flowing after 3,000 years of being dry. Who would have guessed? And then look at over here. You got parts of Iran. This blue is like record rains. So Afghanistan with record rains, Iran with record rains. Take a look at that. I wanted to zoom in for you. So what you saw in the Afghan floods, this is all the exact same in the blue areas here of Iran. Now, Iran's very much a desert area. Now it's starting to rain. What kind of food could we grow there? And look how big that grow zone would be. So would you want to flip the politics to get your feet in the door on a new grow zone? This is Saudi Arabia with the blooming fields here. This is also Saudi Arabia with the camels walking through the purple flowers. This is Oman forming lakes after the third typhoon rolled through there. These are lakes forming in the Omani dunes. Now these are vast changes here. Here's a good zoom in on it. Dry before the floods, Oman and Yemen, they call it the dry quarter for a reason. It's the border of Saudi Arabia, Oman, and Yemen, that area they're fighting for, and you hear about the war right now. That area is this. What changed? Magically, they want to have that land now. I wonder why. Now here's another outlier. I'm going to take, this is the mid-Holocene, or 6,000 year to 4,000 year time period. The X's are where previous precipitation was, or lakes up in the Sahel and the northern, all the way over from Sudan, clear over to Morocco. Where you see a black square is where the water is and was 6,000 to 4,000 years ago. Now I found this here, this is the Chinese investment project map. So I started to match this up, and you can see a lot of concentrations of overlays of where the Chinese are, specifically in these areas. In the middle of the desert, building thermal plants for some reason, like in the middle of Chad. And again, you here show the one here with the elephant, and we both find the same stuff, but there was also giraffes. But these are the cactus in America, and our deserts got covered in snow.
Sorry, do you mean by thermal plants, do you mean electricity?
Yeah, electricity thermal plants. So my thing is, why do they want to build electric thermal plants in the middle of Chad, in the middle of the desert, unless they know that there's something that they're going to need electricity for? Drying crops, processing crops, who knows what. Having electricity for the workers that live in these places, water pumps. They're going to need vast amounts of electricity to do that. So then I just overlaid the two maps together, and you can see a lot of correlations inside here, especially along the Nile River in this section. So this year, record harvests in Algeria, Tunisia, and Morocco for grains. And you can see how these match up here with the Chinese investment projects all through the desert. In the mid-Holocene here, these mega lakes, okay, these lakes were in the middle of the desert. These mega lakes are as big as the Great Lakes in America. So if the rainfall is going to fall, and you know a rain pattern's repeating, you would go where the drainage basin where these lakes were first, because here's where all the riverbeds are, and they've mapped them out already. So instead of going to the center of the lake, which might not fill up first, you might go to a riverbed that's going to drop some smaller lake formation first. And that's where these investment projects are straddling along this termination point here. Somalia floods this is Somalia in 2018 last year. Look how vast that is. And these are areas that we consider some of the driest on the planet. Now this is Valentina Zarkova's research. Again, it's a work in motion. It's not set in stone, but the magnetic fields of the sun, when they cancel each other out, we start to get really weird effects on our planet with jet stream movement. So the wider the wave is, the more our jet streams and cloud cells are going to go out of their normal flows. And there's a lag time here of about 9 months as well. We're in this area here, and we're about to accelerate into this wider gap here this next year. So I would anticipate more intense weather. And we're going to roll through this for a few more years, and then the magnetic fields of the sun are going to try to recouple and reignite themselves, if you will. And after that, they're going to fall far apart again and then cancel each other out. So I'm really curious what happens in here when the sun goes from canceling phase back to some activity to canceling phase so quickly. That's going to be a really interesting time period for us to learn a lot about the sun. Now, speaking of China, they're going to grow the food in Sudan, and they're going to send it through the string of pearls back to Myanmar. There it is again. Isn't that interesting? And then they can take it from Myanmar over into China without having to go through the Malacca Straits, which American military controls. American military is trying to get Aden, this port here in Yemen, along with the Grow Zone, to control the Arabian Sea. China owns Port Sudan. They're not going to get that. They're going to use that for food shipping. And the Silk Road is the Chinese Silk Road. For those of you who don't know, there was a southern Silk Road along the maritime route, and then they had the Silk Road camels walking on the sand kind of Silk Road. But between the patterns here, the Chinese have mapped out this entire area for 4,000 years. They know where the climate's going to shift. That's why they moved their investments there, to get the food grow zone before it's a food grow zone. The land's almost free. The governments gave them, like a million square, hectares for free. Just come and we'll give you a million hectares for free. So they already know where the changes are going to be. And so does the European government. So this thing called the European Neighborhood Policy, part of the Unified Defense Pact that's coming up with the Unified Defense Forces. Look at that. Look where they're going to control. Isn't that interesting why they're down in North Africa? And there's also this other thing called the Union for the Mediterranean. It's a treaty within the EU Unified Defense Force and the EU Neighborhood Policy, both focusing on North Africa. Why is that? Why are they so interested in that? Well, if you look at the old Roman grain growing zones, you'll start to see why. And now it's increasing with rainfall. Yet there's a whole bunch of angry guys living there that would probably say, don't take our food. Unchecked immigration is getting them out of there right now. So this explains a lot of the immigration policy, at least in my own opinion. They're getting the fighters, the resistance fighters, out of there now, while the grow zones are being, let's say they're coming into fruition at the moment. Now, if you live there, would you fight for your food? Yeah, I might want to keep it in my country too. I wouldn't want it exported. But 4 million men have left that area of the world so far. 4 million. China's largest army in the world, 2 million. They exited 4 million people out of there already, men. That would be a 4 million man army that they already got out of the fight. They're not going to be there to resist. Now, Weiji, this is the Chinese word for danger, opportunity in the crisis. So this is what we want to talk about as the solutions, because this is kind of where our crops are going to go. We're going to be harvesting in the snow like we are this year. And what's coming out of that? Bad yields inside there. But this is the American crop production and harvest at the moment. Pretty much looks like this. And the snowfall that Piers had referred to, saying it was far above the averages. Well, here's how far out of the standard deviation it was for 2018 and 19, and how far out of the deviation it was for 2017-18. And this year, it's far out here starting already. I should have put, this is from the Finnish Meteorological Institute. But this year so far, we're starting out here somewhere for this fall, way out here outside of these two record years before us. This 2019 year now is out here. And again, you take a look at the Greenland ice gain. Blue is gain. 2000, what's that? 16, 17, 15, 16, 17, 18, and now it's offline. So you see how the ice has been gaining. These are gains on Greenland, total Greenland, not just a specific glacier, but all of Greenland. And you can find this at the Danish Meteorological Institute, who maintains the ice flow data and ice data for Greenland. This page was offline when I looked for it last, so I put that offline. We know where the crops are going to be lost here. The dark blue means crops are going to be lost. The yellow area is getting hotter, and you see these in the news. Alaska's hotter, Greenland's hotter. These areas in America have gone offline. I did these charts in 2017, forecasting losses here, here, and here, and it's already happened. And then we look in Australia, again, same areas, Mali and West Australia. Australia is a net wheat importer now. They can't export, they don't grow enough. And then we have these parts of China here in Heilongjiang, and then the central area. Their grow zones are down here too. And the Chinese dynasties collapse when the temperature decreases. So it's a very easy correlation to see when the Chinese have trouble, and dynastically is when they reach the bottom peaks. And these are the classical dates given for a collapse of a dynasty by just researchers and historians in China. So you start to match them up. Modern minimum here, what was that? The Ming Dynasty collapsed. Oops. So our grow zones are going to shift further south, meaning that we're more northerly grow zones, they're not going to be able to grow as much, and the yields are going to be much lower. So we have to think about substitution crops. So we're going to have to think about grow zone crops to shift. Go ahead. This is what I'm doing with my own personal take on it. I'm using vertical grow tubes here to try to do different types of lettuce and superfoods. Currently on a balcony in a city to show that you can do it in a city first, and then we can do it and retrofit it. Coal mines, in disused shopping malls, foreclosed homes, whatever it could be. We could put these, we got to start thinking about vertical agriculture indoors right now. And these are the solutions we need to talk about. There's a new type of all-in-one spectrum LED lighting that Brad Buttrick's putting out, but this is a new grow lamp that's using 36 watts, and it encompasses 4 different waves from the sun here to mimic the sun to get a better response for growth. And again, you know, you could put it inside here. This is the basement. This is Brad's basement. He's doing some indoor. And this is about how large we were able to get the plants, not using the grow lights, but outdoor and natural light. But you can still get some pretty good yield off the tubes. And Omega Garden here, this is a rotary disc. The water's at the bottom, and they bring the plants around to the water. And the lighting system is in the center there, so you're getting continuous lighting around the center. And then you can stack these in a shipping container and move them around. You can see the lights in the center. Now the plants bend, like when it comes right around this edge here in this quarter quadrant and up here, the plant stems are bending and the cells are bending, the cellular structure. So it strengthens the plant and they get higher yields because of the bending of the stems during the first growth period. And then eventually when they come to harvest, their yields are quite high and they're faster because of the bending of the cellular structure as it moves back and forth through the water around one turn. We need power, so how about gravitational vortex power, where these are wherever we have stream flows, we can get some new power. But anyway, thanks for listening. Hope you got something out of it. Piers, thank you so much.